For decades, we searched for life in places that looked like home. Warm, bright, familiar. We were wrong. In 2005, a spacecraft flying past one of Saturn's smallest moons detected something that should not have been there. What followed was nearly 20 years of discoveries, each one stranger than the last, that quietly reshaped where science looks for life and what it believes life even needs. But that moon was just the beginning. Because orbiting the same planet, there is a second world, larger, darker, and so chemically alien that if anything lives there, it would defy every rule of biology we know. This is the story of two moons, one hiding an ocean in total darkness, the other raining fuel from a sky that has never seen blue. The moon is called Enceladus. It is 313 miles across, roughly the size of Arizona. A small, frozen world, buried under a shell of ice, orbiting Saturn nearly 900 million miles from the Sun. For most of history, no one paid attention to it. Then Cassini flew past its south pole. What it found altered the direction of astrobiology. Cassini's cameras captured columns of water vapor and ice erupting through long fractures near the South Pole, each fracture stretching over 80 miles. The jets were rising hundreds of miles into space. They were not coming from the surface. They were coming from somewhere deep below. Beneath that ice, Enceladus holds a global ocean of liquid water, estimated to be more than 15 miles deep, sealed under a frozen crust, in permanent darkness. No sunlight has ever reached it. No sound escapes it. An entire ocean, sealed in darkness, existing for longer than anything has been alive on Earth. But what is in that water is what stunned the scientific community. When Cassini flew directly through the plumes and analyzed the material being ejected, it found sodium salts, evidence of water in long-term contact with a rocky seafloor. Then complex organic compounds, including precursors to amino acids. Then molecular hydrogen, a chemical fingerprint of hydrothermal vents, the same kind of environment where life on Earth may have first appeared. Then, in 2023, phosphorus, the last of the 6 chemical elements that every known living organism requires. Carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. All 6 confirmed in the ocean of a moon the size of Arizona. And that same year, scientists identified hydrogen cyanide in the plumes, the molecule most origin of life theories consider the starting point for building biological structures. What are the chances that every ingredient required for life ended up in the same ocean, on a moon 300 miles wide, nearly 1 billion miles from the Sun? No one expected this. Imagine sinking through that ice. Miles of frozen silence, pressing against you from every direction. Then, open water, total darkness, no surface above, no visible floor below. Just black, cold ocean stretching in every direction. The water presses against you from all sides, not violently, but constantly. The temperature hovers just above freezing. And somewhere far beneath you, on the seafloor, the faint thermal glow of hydrothermal vents, cracks in the rock where heated water rises through mineral-rich chimneys, carrying the same chemistry that may have ignited life on Earth 4 billion years ago. If something exists down there, it has never seen light. It has never known a sky. It survives on chemistry and heat alone, in an ocean no instrument has ever directly touched. And Enceladus does something no other ocean world in our solar system does. It delivers samples. Those plumes erupting from the South Pole carry material from the deep ocean directly into space, launched through fractures in the ice at hundreds of miles per hour. Some of it falls back as snow. Some escapes into orbit and feeds Saturn's faintest ring. Cassini caught it mid-flight and read its chemistry. The question is no longer whether Enceladus has the ingredients for life. It does. The question is whether they ever assembled into something alive. 900 million miles from the Sun, orbiting the same planet, there is a second world that demands a different kind of attention. Titan. It is larger than Mercury, over 3,200 miles across, and the only moon in the solar system wrapped in a thick, opaque atmosphere. From space, it resembles a smooth orange marble. No telescope could see through its haze until Cassini arrived with radar and peeled the veil back. What it revealed was without precedent. Rivers, lakes, coastlines, rain. Not water. Liquid methane and ethane pooling and flowing at 290 degrees below zero. If you were standing on Titan's surface, the ground beneath you would be water ice, frozen so hard it behaves like bedrock. The sky above, a dim and permanent orange. And from that sky, methane rain would drift down through a haze of organic compounds so dense it blocks the sun entirely. You would not see a single star. Titan is not a place where life as we know it can survive on the surface. It may be something stranger, a world where the chemistry that precedes life is unfolding in real time on a planetary scale. Its atmosphere, battered by solar radiation and cosmic rays, generates complex, carbon-rich molecules continuously. Scientists have identified among them compounds remarkably similar to the molecular building blocks that existed on Earth before the first cell ever formed. And deep beneath Titan's frozen surface, gravity measurements suggest yet another hidden ocean. Liquid water mixed with ammonia, sealed under miles of ice. Two possible environments for two entirely different kinds of chemistry, stacked on top of each other on the same world. What happens when those reactions run for billions of years in an environment nothing like our own? No one knows. That is exactly why we are going. In a clean room in Maryland, engineers are assembling a machine right now. It is called Dragonfly. A nuclear-powered rotorcraft the size of a small car, designed to fly through Titan's dense atmosphere and land at dozens of different sites across the surface. It will launch in 2028. It will travel for 6 years across nearly 1 billion miles of empty space. If everything holds, it will touch down on Titan in 2034. Its instruments will sample the ground, analyze the organic chemistry, and measure how far prebiotic processes have advanced, how close Titan's chemistry has come to crossing the threshold between raw material and something that could, given the right conditions, become alive. We spent decades searching distant stars for another Earth. The most compelling evidence was closer than we imagined. Buried in ice, dissolved in methane rain, drifting through the dark around a planet we thought we already understood. The answer was never written in light. It was waiting in the dark,